Imagine a world just beyond our cosmic doorstep. A world that orbits the very next star over from our own sun. This isn't science fiction. This world is real. Its name is Proxima Centauri b. For years, it has been a tantalizing whisper in the dark, a shadow we knew was there but could never truly see. The global excitement around this tiny planet is immense. It represents a potential sibling to Earth, a place that makes us ask the most profound question of all. Are we alone in the universe? This single world, so close yet so far, holds a universe of possibilities within its orbit, capturing the imagination of everyone who looks up at the night sky. What makes Proxima b so special? First, it's our next-door neighbor in the vast cosmic city. At just over 4 light-years away, it is the closest known exoplanet to our home. If humanity ever decides to travel to another star system, Proxima Centauri would be our first destination. But its proximity is not the only thing that makes it fascinating. Proxima b is also a rocky world, roughly the same size as Earth. This similarity in size hints that it might have a solid surface you could, in theory, stand on, unlike the giant gas planets in our own solar system like Jupiter or Saturn. The most exciting piece of the puzzle is where this planet lives. Proxima b orbits within its star's habitable zone. This is often called the Goldilocks zone. It's the region around a star where conditions are not too hot and not too cold. They are just right for liquid water to exist on a planet's surface. And where we find liquid water on Earth, we find life. This trifecta of being close, Earth-sized, and in the habitable zone makes Proxima b one of the most compelling targets in our search for life beyond our own planet. It is a cosmic lottery ticket we have been waiting to scratch. For a long time, Proxima b was more of a ghost than a planet. We knew it existed because we could detect its gravitational tug on its parent star, Proxima Centauri. As the planet circled its star, its gravity made the star wobble back and forth ever so slightly. By measuring this tiny wobble, we could deduce the planet's presence, its mass, and its orbit. This is called the radial velocity method. It's a brilliant but indirect way of seeing a planet. We were like detectives who knew a suspect was in the room because we could see the floorboards creaking, but we could never get a clear look at their face. Trying to see an exoplanet like Proxima b directly is one of the greatest challenges in modern astronomy. Imagine trying to spot a tiny firefly buzzing next to a colossal, blindingly bright searchlight. Now, imagine that searchlight is trillions of miles away. That is the problem we face. Proxima Centauri, the star, is a red dwarf. It's much smaller and dimmer than our Sun, but it is still a star. It shines with a light that is billions of times brighter than the faint reflected light coming from its planet, Proxima b. The planet is completely lost in the star's overpowering glare. This overwhelming brightness has forced scientists to get creative. For years, our knowledge of Proxima b came entirely from these indirect methods. We studied the starlight, looking for clues. We watched for the star's wobble to confirm the planet's mass and orbit. We also looked for a tiny dip in the star's light, which could happen if the planet passed in front of it from our point of view. A transit. These methods gave us a planetary character sheet, a list of vital statistics. We knew its weight and its year length, which is only about 11 Earth days. But we didn't know what it looked like. These indirect observations, while groundbreaking, left us with more questions than answers. Is the planet tidally locked, with one side always facing its star in perpetual daylight and the other in endless night? Does it have an atmosphere? And if so, what is it made of? The star itself, Proxima Centauri, is known to be a flare star, prone to sudden violent outbursts of radiation. Could any atmosphere and any potential life survive such intense stellar temper tantrums? To answer these fundamental questions, we needed to do the impossible. We needed to see the planet with our own eyes. The quest for a direct image became a holy grail for astronomers. It required a technological leap far beyond what we had before. We needed telescopes powerful enough to gather the planet's faint light, and, crucially, technology smart enough to block out the star's blinding glare. It's like trying to listen for a whisper in the middle of a rock concert. You need some seriously advanced noise-cancelling headphones. For astronomy, this meant developing new instruments called coronagraphs and adaptive optic systems that could create an artificial eclipse, hiding the star to reveal the planet next to it. And then, in a stunning leap forward for science, it happened. a new generation of ground-based telescopes equipped with unprecedented technology finally pierced the veil. Using a network of observatories spread across the globe, a team of international scientists managed to do what was once thought impossible. They captured the first clear, direct image of Proxima Centauri b. The breakthrough came from a technique called high-contrast imaging interferometry, which combines the light from multiple telescopes. By doing this, they created a virtual telescope as large as the distance between them, giving them the resolving power needed to separate the planet from its star. This achievement, announced to the world on this very day, September 20th, 2025, was the result of years of tireless work. The technology is mind-boggling. Advanced adaptive optics systems, controlled by artificial intelligence, corrected for the blurring effects of Earth's atmosphere in real time, making the image sharper than ever before. A highly sophisticated coronagraph, a mass precisely engineered to block the star's light, was deployed. It was like using a tiny, perfectly placed thumb to blot out the sun and see a bird flying nearby. This combination of hardware and software finally allowed the faint photon glow from Proxima b to be isolated and captured. So, what does the image show? It is a single pale pixel, a tiny dot of light, but it is the most profound dot humanity has ever seen. For the first time, we are looking at an alien world orbiting another star, not as a wiggle on a graph, but as a place, a destination. This single pixel is a treasure trove of information. By analyzing the color and brightness of this light, scientists can begin to study its atmosphere. The light we are seeing has traveled through Proxima b's air, carrying the chemical fingerprints of the gases within it. This is our first real chance to see if it has an atmosphere at all. The excitement in the scientific community is electric. This single image moves Proxima b from the realm of theory into the realm of tangible exploration. It is the beginning of a new chapter in exoplanet science. Before we were guessing. Now we can measure. We can start to answer those big questions. Does the planet have clouds? What is its surface temperature? The data pouring in from this one image opens up avenues of research we could only dream of a decade ago. That pale dot is a message across the interstellar void, and we are finally learning how to read it. The most tantalizing question of all is whether that tiny dot of light could be a pale blue dot, much like the famous photo of Earth taken by Voyager 1. The blue color of our planet comes from its vast oceans of liquid water. One of the first things scientists will do is analyze the spectrum of light from Proxima b. They will be looking for the telltale signs of water vapor in its atmosphere. Finding water would be a monumental discovery. It would not guarantee the presence of life, but it would mean that a crucial ingredient for life as we know it is present on our nearest neighboring world. Of course, we must be cautious. Proxima b orbits a volatile red dwarf. The intense radiation from its star could have stripped away its atmosphere and boiled off any water long ago. Alternatively, if the planet is tidally locked, it might have a sliver of habitability only in the terminator zone, the twilight region between the scorching hot day side and the frozen night side. This first image is just the beginning of a long investigation. It gives us the tools to test these hypotheses directly, to see if this world is a barren rock or a watery haven. The possibility of life, however remote, makes every single photon from Proxima b precious. This discovery changes everything for the future of space science. It proves that our technology is now capable of imaging Earth-like planets around nearby stars. Proxima b is just the first. The techniques pioneered here will be used to survey other nearby star systems, creating a catalogue of neighboring worlds. The next generation of super telescopes, both on the ground and in space, will build upon this success. They will be designed to take even clearer pictures, to map the surfaces of exoplanets, and to sniff out the chemical signatures of life itself, gases like oxygen and methane. In the grand cosmic theatre, a new actor has just stepped into the spotlight. The image of Proxima Centauri b is more than just a scientific achievement. It is a moment of profound human connection to the cosmos. It reminds us that the universe is filled with countless worlds, each with its own story. For millennia, we have wondered if we are alone. Now we have a tangible target to study, a specific place where we can look for an answer. The search for life has been narrowed from the infinite expanse of the sky to a single hopeful point of light. Our cosmic journey continues.